Finding trig functions of special angles. Here's the unit circle. Just so we're clear, it's a circle of radius 1 centered at the origin. Then all the points on the circle have coordinates that correspond to the sine and cosine of an angle formed by a line from the origin through that point and the positive x-axis. Cosine is the x-coordinate. Sine is the y-coordinate. Because the circle is centered at the origin, it's cut into 4 pieces with 1 in each quadrant. Recall that x and y change sign depending on which quadrant the point is in. Both are positive in the first quadrant. X is negative, y is positive in the second quadrant. Both are negative in the third quadrant. X is positive and y is negative in the fourth quadrant. Since cosine and sine correspond to x and y respectively, their signs are the same as x and y in each quadrant. Because of the nature of sine and cosine, we can use reference angles to find the sine and cosine of any special angle we want. To find the reference angle, we will find the angle that the terminal side of my angle forms with the closest side, positive or negative, of the x-axis. Therefore, if my angle in radians is alpha, then the reference angle in the first quadrant is simply alpha. Reference angle in the second quadrant is the distance between pi and alpha, or pi minus alpha. In the third quadrant, since alpha is greater than pi, it's alpha minus pi. And in the fourth quadrant, we're back to using the positive x-axis. So it's 2 pi minus alpha. Here are the relationships that each of the other 4 trigonometric functions have with sine and cosine. As you can see, each one can be written in terms of sine and cosine, so we only need to know the sine and cosine of each angle. Then we can use these identities to find each trig function. Tangent is sine over cosine. Cotangent is cosine over sine, or 1 over tangent. Cosecant is 1 over sine, and secant is 1 over cosine. Because of reference angles, we only need to know 3 values for sine and cosine. Here are 2 common right triangles that we will use for sine and cosines. In the left one, we have angles measuring pi over 3, pi over 6, and pi over 2, the right angle. Corresponding side lengths of 1, square root 2, and 2. The right one is an isosceles triangle with angles measuring pi over 4, and pi over 2. Corresponding side lengths of square root 2, and 2. When finding trig functions in right triangles, use SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Therefore, the sine of pi over 6 is 1 over 2, or 1/2. And the cosine of pi over 6 is square root 3 over 2. This also means that sine and cosine for pi over 3 are flipped from pi over 6, since the opposite and adjacent sides are flipped. For pi over 4, since the angle is in an isosceles triangle, sine and cosine are the same. Both are root 2 over 2. What does this all mean? Well, to find the values of the 6 trigonometric functions of any special angle, that is, any multiple of pi over 3, pi over 4, or pi over 6, there's a process you can use. The first step is to figure out what quadrant the terminal side of the angle is in. This will tell you what signs, positive and negative, your values of sine and cosine will take on. Then, you figure out what angle will be your reference angle by using the method we saw earlier. Third, find the exact values with correct positive and negative signs for sine and cosine of that angle. Finally, use those values to find the remaining 4 values. Now here's an example of how you would go about finding the values for the trig functions of a given angle. Our angle is 5 pi over 6. Since 5 pi over 6 is greater than pi over 2, but less than pi, its terminal side lies in the second quadrant. Subtracting 5 pi over 6 from pi gives us a reference angle of pi over 6. Therefore, since we're in the second quadrant, the sine of 5 pi over 6 is negative 1/2. Since sine is negative in the second quadrant, and the sine of pi over 6 is 1/2. Cosine of 5 pi over 6 is square root 3 over 2. Since cosine is positive in the second quadrant, pi over 6 cosine is pi over root 3 over 2. The remaining values can be found using those 2 values. Tangent is sine over cosine, so tangent of 5 pi over 6 is negative 1/2 over square root 3 over 2. After reducing, get a fraction with a square root on the bottom. Means we have to rationalize the denominator. The result is negative root 3 over 3. Cosecant is 1 over sine, or the reciprocal of sine. So it's just negative 2. Secant is 1 over cosine, or the reciprocal of cosine. So again, we have a fraction, and we have to rationalize its denominator. And the result is 2 root 3 over 3. Finally, cotangent is sine or cosine over sine. Or root 3 over 2 over negative 1/2. This time, after reducing, we simply get negative square root 3. And there are all 6 trigonometric functions for 5 pi over 6. Thanks for watching, and we'll see you next time.